Hi everyone. So this video is about how Halo scaled to 11.6 million users using Saga pattern. So Halo was a game which was earlier owned by a company called Bungie and later it was acquired by Microsoft. The era was around 2001, sort of that era. I am exactly not sure at what point of time this game was, but more or less it was around that year. So there was a rule that each game has 32 players and every player is able to see what score they have, what points they have scored. So starting with the very naive approach, let's suppose if you have a RDBMA system and it's a single instance. So the request goes to this RDBMA system and this RDBMA system records every player points, and then you have a only single just get my pen, yeah. So only single database you have, and then for that database every request is going on, and then you basically record everything into a single instance. But obviously if the number of users is in millions, single instance of RDBMS will not work. I'll not go into much detail because it's well known that it won't scale for those millions of users. So the approach to which they took is that they used Azure NoSQL database for storing the data. So they moved from RDBMS to Azure NoSQL database, and they used partitioning for partition the data into multiple partitions. Since single NoSQL instance won't be able to handle those many million users data, so they chose partitioning. The two most critical requirements which they have to fulfill when they moved from RDBMS to NoSQL is that atomicity. So when you have partitioning, there are one situation that, let's suppose you have four partitions, let's suppose you have three partitions, and two, if I am writing something, two gets the right and one don't get the right due to, let's suppose, the partition was not up at that point of time. So what implication it will have on the game, that let's suppose me and my three players are playing the game, I will see a stale data, a data which is outdated and it is not written, basically not the right word outdated, but it's inconsistent data. And then the other two players will be able to see their score perfectly, but my score will not be visible because the write has not happened, and the write at that point of time my partition was down. That is atomicity. Now second part is that they need to achieve strong consistency. So what do you mean by this is that, let's suppose there is a state which I have three partitions. I have done a write, and after that my ideally the state should be S1, S1 and S1 of a transaction, but for some reason there was a network latency while it was writing, and then my this partition has only got state 0, earlier state. So ideally all should have S1, S1 and S1, but due to S1, sorry, due to some network latency it went to it didn't go to S0, and when I'm reading a stale data. So they need to achieve strong consistency here. So what solution they did? What they did was they applied a Saga pattern. So there are multiple patterns when you're designing microservice. One is Saga pattern and one is two-phase commit pattern. So I'll discuss two-phase commit pattern in a different video. So in the Saga pattern, so I'll just briefly explain what is Saga pattern. So let's suppose I have a service S1 and I have multiple other services which basically are talking to S1. So these services can be, let's say you can say order service, and it is talking to inventory service, logistic service, and let's suppose payment service. So these are three services which it is talking to. Now this order service makes a call to inventory service. So S1 is making a transaction 1 to S2 service, and S2 service returns the success to S1. Now since we know that after making the inventory, deducting the inventory from the inventory service, then only I move ahead for the payment. So this is my transaction 1, this is my transaction 2, and let's suppose my transaction 2 got failed. so it returned a failed. So what order service will do, it will make a compensating transaction to the inventory service, so that my deduction gets reverted, so my data didn't get into a inconsistent state. So this is basically a Saga pattern using orchestration. There are other ways also where Saga pattern implies. Saga pattern using choreography is also there. We'll discuss some in some other video. So if one service returns a failed transaction to the orchestrator service, it basically reverts all the transaction, which we call it a compensating transaction, to all the other services. So that's how the Saga pattern works. Now they use the same pattern to apply consistency and atomicity in the partitions. So let's say so they made a service called orchestrator service, and this orchestrator service gets a request of, let's suppose, increment of that point, game point. So this orchestrator service makes a call. So first of all, what it does, it makes log to a distributed log system. So they also had let's suppose for it now call it a T log system, and pardon me for my writing. And once the orchestrator gets wants to execute a T1 to P1, so let's suppose I have a T transaction. What I will do, I will subdivide this tree, this T, into sub transaction, which is T1, T2 and T3. T1 wants to get executed to P1 partition, this is P2 partition, and this is P3 partition. If all partition get success, then only orchestrator returns the success to the callers. So the orchestrator wants to, so first of all it logs everything to this logging log system, and then once it is logged, so start T1. So what it will do, when it is making call to P1, it will make a start T1, and then when it gets a success, it will make that, okay, my commit T1 is success. Then it starts T2, then it again gets a success, that okay, my commit T2 is success. If let's suppose in the similar fashion I am executing n sub transaction and my Tn transaction gets failed, so my start Tn transaction gets logged and my commit of Tn transaction get failed. So this orchestrator service will revert all these transactions. We call it a compensating transaction. So what we do is basically, instead of just deleting it, we can just cancel it. So that's like how you do in sort of reservation system. So either you can delete it or you can just make a cancel, that okay, this transaction was not able to get success, so just cancel that transaction. So this is how they implemented this Saga pattern using orchestration. So what they made sure is that they use a reliable and distributed log system, so that my logging system don't get failed, and my orchestrator is always stateless, which help them to basically revert from any state. Now from the above architecture, what it helped them to achieve is that they had now all the record failed, they record every failed transaction, and they execute compensating transaction because they have the log of every whatever got failed and whatever got started. And this is very important, this is very beautiful way of designing using Saga pattern, is that let's suppose my partition was not up. So this was my 3 partition and one partition was not up. So what I can do is that this partition was not up and these were up. So let's suppose when I am, so this returned when T1 got success, then T2 got success, and this got down when I was making a compensating transaction. But as soon as it gets up, so 2 things. One is that I'll be able to make a compensating transaction to T2 and T1. And since nothing gets written to this database, it just came up with the right amount of right state. Now let's take a condition where let's suppose there is 3 transaction, and at the point when I was writing, what it did, that it failed my transaction and my T1 and T2 got success. This is T3. T3 got failed. So I need to make a transaction T1 and T2 also fail. But at that point of time when I'm making T2 fail, it got, when I'm compensating, making compensating transaction, it got success. But let's say when I am making a T1 transaction, this is the partition went down. But at this point of time, I exactly know that which transaction I have to execute once the partition is up. So it's very easy for partition uh, to make them a very consistent throughout the transactions. And when the system is going and up also, your data is not getting inconsistent. So yeah, that was about. So it was, there was a very beautiful article by Neochem. So you can just go through it. I will just link this URL in the information below. Yeah, so that's all for today. Thank you.